name is Felix Carrion, and in this lab we constructed models that simulated and analyzed the object moving at constant velocity using Tracker and VPython. In this, we implemented Newton's second law, in which velocity in the future can be predicted by initial velocity and the product of the net forces and delta time. In this case, we assume that the net forces equal 0 in all directions, so that final velocity equals initial velocity and there is no acceleration. By using VPython, we simulated the outcome of our experiment, and we also analyzed a video of the ball moving in motion. And by taking position versus time, we constructed a informational graph with both elements. And we can see that the projected outcome had an estimated velocity of 0.04 meters per second, and the experimental outcome was very similar in that average rate, but there are many irregularities due to both time and usage of the software. So, if these axes in Tracker were to change, or there would be a difference in orientation, the only difference would be that the axes themselves would still point in different ways, but the difference in distance would be the same, and the time would be the same also. So this looks at the difference in direction rather than whatever direction it would be. So it would always move in the positive direction. As for the F-net, it is impossible to say the total number of pushes and pulls, but mostly the drag force would be pushing against the movement of the ball, and gravity would be pushing against the normal force. But since those were not completely canceled out to get a net force of 0, that's how you get the irregularities within the lab data. So yes, that concludes our experiment. It shows that this follows Newton's second law, and it is visualized in this